Welcome to my channel. I am Dr. KP Naidu. In this lecture, I am going to discuss about end-to-end machine learning project and how to use that machine learning model in user interface. So in this video, I am taking the iris dataset. So first try to understanding this dataset. This dataset contains 1, 2, 3, 4, 5 features, okay, and one target variable species. In these 5 features, okay, we no need the feature of feature ID. That's why first we have to removing this feature. So for building a machine learning model, we require these 4 features, that is sepal length, sepal width, petal length, petal width, okay, with the diameter, with the uh, centimeters, and the target variable is species. The species target variable contains 3 columns. One class name is iris setosa, another class name is iris versicolor, another class name is iris virginica. That means the target variable contains 3 classes. Okay. So first we are trying to understanding how to read the data and how to prepare the data before building the model, and then how to split the data, and then how to build a model and how to perform the predictions. Then we have to build a user interface to predict the class of the given instance. Okay, so guys, we are moving to the code. The first step is, first we have to import the required libraries for build a machine learning model and to create a user interface. So to create user interface for a machine learning model, in this I am using the Streamlit library. For building a model, I am importing the NumPy library and the pandas library. Okay, and for splitting the data for train and test, that train and test class we are having in a library called as sklearn.model selection, and in this I am using the supervised machine learning algorithm, that is KNN classifier algorithm I am using to build a model. Okay, that was contained in a library, again sklearn.libraries, to display the accuracy of the model. Okay, here we are using the library called as sklearn.matrix. This is the library. From this library we are importing the class accuracy score. This accuracy score is helpful to display the accuracy of the model. Okay, guys, hope understood these libraries. Okay, so before building the model, first we need to read the data set. Okay, so to read the data set in pandas, we are having the function called as read underscore CSV. The read underscore CSV is the function of the pandas library. That's why here I am creating instance PD for pandas library. That's why from PD dot read from PD instance we are read the our dataset with the function called as read underscore CSV. That's why pd dot read underscore CSV. This is iris dot CSV. Here I am directly written the iris dot CSV. Why? Because so where I am saving this by Python file, in the same folder only I am maintaining the iris dot CSV. Let's see this our file, and what is called as iris dot, sorry, okay, this iris data dot py and iris dot csv having in the same folder. That's why I'm writing the iris dot csv. For example, if it is two different iris dot py in one folder and iris dot csv in another folder, then here we need to maintain the path of this file. Hope understood. Okay, then we are using, it creates, what the statement creates is the pd dot read underscore csv file returns a data frame. Returns a data frame. Clear? So what the data frame? The data frame contains, it is display, it will gives the output as some tabular format that first contains the column names. Okay, then the rest of the records contains the values of the columns. And after getting the data frame from this function, then we are using the df.head. The df.head function displays the top 5 records of the data set. As we already know that, okay, from the, this is initial data set. From the data set we have to drop the id column. Okay, so to drop the id column we are having the function called as drop. Clear? Then what is the column name here? id. Okay, that we have to make it in a, place it in a single column, and access equal to 1. So access equal to 1 means we have to removing the entire column. Clear? So in place equal to true. So the purpose of this in place parameter is, if we can place, if we can maintain in place equal to true, it's completely removing the id. It's completely removing the id column from the iris.csv. Rest of the data can be maintained as it is. Clear? For example, if we are maintaining in place equal to false, to this statement only it can removing the column name. But another time, if you need some the same data, okay, we need to have again that id is having in the data set. That means if you are maintaining in place equal to true, it completely removes, permanently removes the id column from the data set. It permanently removing the id column from the data set. For the purpose we are using the in place equal to true. Clear? And another one is, here we are using the x and y. Okay, so in x we are maintaining the entire the data of the futures only. In the y we are maintaining the entire data of the target variable. Hope understood? In x we are maintaining the futures data only. In y we are maintaining the target variables data. So but actually what we are having in a data frame, in data frame, here we are reading, here we are drop the id. If we drop the id from the data frame, what we are having? Sepal length, sepal width, petal length, petal width, and species. So from this, in x we are maintaining the data of these features. In y we have to maintaining the data of the species. That's why from the data frame, first we have to drop the species. After dropping the species, the remaining data we have to keep in x, and the species column we have to maintaining in a which one? Y. For that I am writing the code like this. X equal to df dot drop of, I am dropping the which one? A species column. Okay, comma, x equal to 1. That means after removing the species entire column, okay, the entire column if you want removing, we are using x equal to 1. It drops the entire column. Clear? From the which one? Data frame. The rest of the data we have to assign to which one? X. So here let's see, in place equal to, I am not getting the true. Why? Because it is not permanently removing the species. Okay. So logically the species is having in the data frame. Why? Because by default in place equal to false. If you keep in place equal to true here also, completely species was removed. That's why again we need the species column. That's why here I'm not writing the in place equal to false. Hope understood. Then after dropping the species column from the data frame, and from the data frame the species column, that is the target variable column values data I have to maintaining in a y. Okay. Now that means up to now the x contains all the features data, the y contains the target variable data. Now, before building the model, we have to split the data. To split the data, we are using the function called as train test split. To train test split, we are passing x, that means enter the features data, and y, that is the target variable data, and test size equal to 0.2. That means what is the ratio we are using for training the data and what is the ratio we are using for testing the data. Here I am using the test size equal to 0.2 means 80% of the data set used for training. The remaining 20% of data is used for which one? Testing. Clear? Again, one more parameter is random state equal to 42. Here no need to provide in the random state equal to 42. In this place of 42 we may providing any value. But what the purpose of this random state parameter is, for example, if you're building the model, okay, for example, out of 100 records, let's assume you're having data set contains 100 records. The first 80 records contains, let's assume it training. The rest of the 20 records may be split as a test. After building the model, okay, we're getting some accuracy, something like that. The second time, if you are running the same if you're running the program on the same data set, what are the records comes into the training data, the same records also we need to get in the second time also. No need to change in the records. Okay. So for that purpose, we are using the random state parameter. It does not change. If you're running any number of times, in the first time what are the records comes into the training data and what are the records are comes into the testing data, the same records that comes into training and testing, even though if you are running any number of the times. For the purpose we are using the random state. The value may be anything, either 1, 2 or 42 or anything. Okay. So here train test split. So in this we are using, okay, the parameters are, okay, so xtrain means xtrain, xtest, ytrain, ytest. The xtrain contains the training data, the training data, the training features data. Xtext contains, xtext contains the features test data. Ytrain contains the features training, what is called, sorry, the target variable training data contains in a ytrain. Ytest contains the target variable test data. The target variable test data. So xtrain, xtext, ytrain, ytest. Once again I can repeat. Xtrain contains, okay, from the training data, the features data, the features training data contains xtrain. The features test data contains xtest. The target variable training data contains xtrain. The target variable test data contains xtest, ytest. That is about xtrain, xtext, ytrain, ytest. Now to build a model, here I am calling the function called as k neighbors classifier. Here I am using the k neighbors classifier. In this the main parameter is the value of k. Okay, if you don't know how it can works, okay, in the below description I can provide in the link how the KNN classifier works. Okay, I was explaining with some example. Just to go through that link, then you can easily understanding how this k neighbors classifier works. Okay, here I am taking the value of neighbors equal to 4. The result is assigned to which one? Model. Then once if you getting the model, that model is fit with the function called as the fit function. To this fit function I am passing, to this fit function I am passing, okay, xtrain and ytrain. To which data we have to build the model? To the training data only we have to build the model. So that where we are having the training data, xtrain contains the features data. The ytrain contains the target variable training data. The target variable training data. That's why we are passing the both the training features data and the training target variable data. That's why we are passing xtrain and ytrain. Okay. So after fitting the model, to evaluate the model dot, okay, we are using the function called as predict. We are using the function called which one? Predict. To the predict function we have to pass which data? test data. What is test data? In which variable will contain test data? X test. That's why to create function here we are passing X test. So once if you are passing the test data to the model, we are getting some predictions. Now these are the prediction values. These are the prediction values of which one? Test data. The actual values of this test data contains in which one? Y test. The actual values of this text data contains in which one? Y test. Okay. So if we are using the function called as accuracy score, to this accuracy score we are passing both actual value of the test data, actual values of test data, the predicted values of test data. By using these two parameters, we are getting the accuracy. Okay, that will be displayed. So till now, hope everyone understood. This is how to read the data, how to prepare the data, okay, how to split the data, how to build a model, and how to calculate the accuracy. Okay, so till now we are just building the model and then this what is called as calculating accuracy of the model. Next we are going to the most important is how we are creating the user interface and how our machine learning model is used in the web user interface, and from the web user interface we have provided input to the model and we are getting the output. That output is again displayed on the user interface. Like that only in the real time scenarios our application works. Okay, so here I am using the Streamlit library. So again I am the Streamlit library. Here I am creating one instance called as st. Hope understood. Okay, first st dot title, that means the title of our application. The title here I am providing is high risk species prediction app. And this st dot write, this is one more function to display the content onto the which one? Browser. In this I am writing the content is this app predicts the species of an iris flowers based on input features. Clear? Again, if you want to display the accuracy in our browser, just we are using the function called as write function, st dot write. Okay, f for some format for specifier model accuracy. Okay, so where we having the accuracy value, we are having the accuracy value in a variable called as accuracy. Okay, so in a write from the write function, if you are writing in a if you are writing anything within double quote, that will be displayed on the user interface web browser. But if the value of a particular variable, if you want to displaying on the user interface, for that we have to providing that variable within the which one? Curly braces. So open the curly braces, close the curly braces. I want to display accuracy in terms of percentage. That's why accuracy into 100 up to 2 decimals. For example, 100.00 something. That is dot 2f means 2 points in percentage. Hope this will be the statement for displaying accuracy on the browser. Okay, now here I am using the one object that is called as a sidebar. Okay, so the sidebar is used in the previous lecture. I am giving how the sidebar is works with the help of the what is called as in the Streamlit library. Just go through that video. Okay, if need that video also I am providing in the description. Just go through that how the sidebar is works. Okay, so now first st dot sidebar dot header equal input parameters. Clear? So that means the window is split into two types. The sidebar is created into left side of the window. In the right side we are having some another part. Okay, that's why I am using the st dot sidebar dot header. The name of I am giving is input parameters. Clear? So now what are input features here? Sepal length. Okay, sepal width, petal length, petal width. Okay, that's why st dot sidebar, in that we're having the slider. We're having slider. Okay, so how the slider look like means just I will show here. Okay, it is just like a, this is a sidebar. Okay, this is the sidebar, st dot sidebar. It is just like a slider. It is just like a slider. Okay, so the slider, we are here I am maintaining the what the minimum value of slider and the maximum value of the which one slider, and also I can maintain the mean of the slider also. Okay, so that is slider. Sidebar is different than slider. Okay, so this is the sidebar, this is the which one sidebar, this is the slider. To each slider, minimum value, maximum value and the mean value I have to maintaining, and this slider name is sepal length, name is sepal length, that is I am writing here. Clear? What is the label here? Sepal length in centimeters. Clear? What is the future name of sepal length? Sepal length centimeters. This feature we are having in a x, as we already discussed, x of sepal length centimeter is a feature name that I want to maintaining in a type float type. That's why float of I am writing here. I have to maintain the minimum value of that sepal length. Clear? And maximum value of the which one sepal length which float type, and the mean value of the sepal length which float type. Likewise, we have to take the four sliders, one for sepal length, okay, another one for which one sepal width, another one for petal length, another one for petal width. Similar way, we are creating the four sliders: sepal length, sepal width, petal length, and petal width. Okay, hope understood till now. Next one is st dot subheader user input features. User input features. So in the subheader, st dot subheader means user input features means we are getting output like this. User input features. So here I want to displaying what are the values we have to select it, that I want to displaying into the browser. For that I am writing the function st dot write, okay, some f sepal length colon the which value I am choosing, that is we are having any which variable, this sepal length variable. That's why within the curly braces sepal length, then I want to give the some new line, that's a slash and slash n. We have to providing the two slash and slash n to get the new line in a Streamlit library. Okay, again sepal width centimeters is a label, and its value we are contains in which one, in which variable sepal width. Okay, that's why I'm writing as a sepal width in a curly braces slash and slash n. Again petal length label, petal length value. Okay, next petal width label, petal width value. Like that we have to displaying the values. Now if you want to predict, here we are reading the values from the sliders. We have to read the value of the which one from the sliders. What we are reading? Sepal length, sepal width, petal length, petal width. Okay, this entire thing I have to maintaining in a data frame. PD dot data frame of, I have to maintaining these four values as a list. I have to maintaining these four values as a which one? One list. One list. These list of values, again another one. These list of values I have to pass to which one? Create as a data frame, and that will be maintained as a which one? New list. So that new list contains what are the values we are selected from this slider. For example, here I am choosing for example 5.03. Okay, sepal width 2.00, petal length 2.65, petal width 0.92. These values, okay, are saved, okay, in a variable called as which one? New test. In which one? New test. Clear? That new test we are passing to, that new test we are passing to which one? Predict function. Okay, so model dot predict of which one? The new test. The new test contains what are the values we are getting from the which one? Slider. Okay, then st dot subheader of which one? predictions. I am displaying as a predictions. Then what the result we are getting from the prediction that I want to display on the browser. That's why I am writing as st dot write of which one prediction. This will used to display the output of this predict function. New test data I am passing. The result will be assigned to predictions that I want displaying on the browser. For that I am writing as st dot write. Okay. So hope understood how to build a machine learning model and how to create user interface by use Streamlit library and how to read the data and how to pass this data to which one a predict function. From this we are getting the predicted class. Okay. So now we have to save this one. Okay. So then we have to open the terminal. Clear. Open the terminal. Okay, then just we have to write cd space, just copy the path, copy path, cd space, copy path, iris data.py. We have to take up, go to up to this path. Then we have to run this one, streamlit space. Okay, run space iris tab data dot py is the file name. Just run it. Okay, so it runs. Okay, the command is not rum. Okay, sorry, it's a run. Okay, so just it will run. It may take some time. Okay, then it will open the browser. Okay, so it is running. Okay, it may take some time, depend upon the here we are writing the code for building the model. Okay, we are having some another approach that is called as we no need to build a model in the what's Python file only, where we are creating user interface. We have to save the model in some file. That file name is directly taken into the Streamlit library. That is another scenario that will be discussed in the another video. Okay, now this is the output. Okay, okay, by default, for example, I am checking as the minimum values like this: sepal length, petal length, sepal width, petal length, petal width. Okay, so this is the prediction. Iris setosa. The model accuracy is how much? 100%. For example, if I am changing to this data, sepal length 4.4, petal length 2.08, petal length 1.08, petal width 0.17, the class is iris setosa. If I am changing, for example, sepal width and also sepal length and also petal length, okay, it the class name is changed. Okay, if you're changing these values, the predicted class is also changing. I'm changing the petal width also, it is changing the class name also. This is the prediction of this given taken input data. That is guys, the complete demonstration about how to providing or how to build a user interface using the Streamlit library. Okay, to machine learning model. From the machine learning model to the machine learning model, we are creating the user interface. Okay, from the user interface we are getting the input of the features data. Those input of the features data we are providing as input to the model. From that model we are predict the class of the this give taken test data. From that we are getting the class of the given the class of the input data. Okay, hope everyone understood. Thank you.